I hope you're all doing great because I'm Mr. Ish. Thank you for joining me. We're looking here at linear motion, which falls at the intersection of mathematics and physics, and many of you in the 12th grade will look at topics such as this: linear motion, an object moving in a straight line. The vectors are always in a single direction at any particular point in time. There's no curve movement at all. Everything is in a straight line, either right, left, up, or down. Everything can be designated by a vector in a single direction, and that's what we're talking about with linear motion. So our question is this: we have a snowball which is thrown straight up into the air from a height of 10 meters with an initial velocity, VO, initial velocity of 25 meters per second. We have to find all of these things. We have to find the time of maximum height of that snowball. We have to find the velocity of that snowball at the maximum height. We have to find the time of impact when the snowball will go up and then it'll come down and it'll hit the ground. We have to find the velocity at impact, and we have to find the maximum height reached of that snowball. It's a lot going on in this question, but I'm going to break this down for you and you will see it's not too hard. At any point the snowball is going up in the air. What is happening at all times? There's always a force on the opposite side having vector component aimed downwards, and that's gravity. And gravity is always, for this particular instance, minus 9.8 meters per second square, because it's always opposing the object moving up. It has a vector direction downwards because gravity is always towards the earth. So we'll keep aside over here minus 9.8 meters per second square is your acceleration factor, so we have to keep that in mind. Minus because the gravity, or the vector of acceleration in this instance is gravity, is aimed downwards. Let's look at question A. At the time of maximum height, we have to remember these equations. Vf is equal to Vo plus At. Final velocity is equal to initial velocity plus acceleration times time. We have to find the time at which the snowball reaches the maximum height. When the snowball is thrown, it goes up. After a while, it'll change direction and then it'll come down. At that instance where it changes its direction and heads downwards is the maximum height, and we have to determine the time of that maximum height. But what will happen when the ball is going up and it comes down? It will reach a final velocity, but at the point of that conversion from up to down, the final velocity will be equal to 0. I'm eliminating the units, but here it would really be meters per second. Anyhow, 0 is equal to your initial velocity. You have 25 plus acceleration here is minus 9.8, and we have to solve for this t. This is just algebra. Minus 25 is equal to minus 9.8 t, and t is equal to, you have to solve it. We'll do 25 divided by 9.8, we'll get 2.55 seconds. So when the snowball is released, after 2.55 seconds it reaches its maximum height, and then it'll start turning down and it'll head in the opposite direction towards the earth. So we'll put here 2.55 seconds. So that question has been solved and it wasn't too hard. We have to find the velocity at the maximum height. This question right here, question B, is a bit of a no-brainer, simply because you could think of it as a trick question. Velocity of the maximum height, the snowball, which was initially headed upwards and then it'll head downwards, the velocity at that maximum height will be 0 meters per second, because velocity is a vector. It's headed upwards with a certain velocity, magnitude, and direction. Then it changes direction, but at that point of that conversion, the velocity is always 0 meters per second, and that right there would be the answer. Without saying too much or repeating myself, the answer here would be just 0 meters per second at the maximum height. So question B has been solved, and it wasn't too bad. We have to find the time at impact. How can you go about doing that? Now we have to start thinking about the position. It will be VOT plus half AT square plus S. Now look, we have S here and S here, but this can be your final position, this can be your initial position, and this right here would be the equation you would apply. And you would have to be solving here for this t. Now look, we have the values which can easily fall in. We have initial velocity here, 25. We have to solve for this t plus half. We know acceleration is always minus 9.8. We have this t square plus SI. What's your initial position? Initial position was 10 meters above the ground plus 10. And that exactly will be a quadratic equation you'll solve. You'll have minus 4.9 t squared, because 9.8 divided by 2 is a minus 4.9 because it's a minus, plus 25t plus 10. And that right there would be your equation you would have to run through utilizing the quadratic formula. Bring in the quadratic formula and you'll have a minus 25. Remember A, B, and C. This is my A, this is my B, C. plus and minus b square, 25 square, which is 625, minus 4ac minus 4.9 times 10 all over 2 times minus 4.9. Now since we're here utilizing the variable t, all of this is equal to t, we can only look at a positive value, so don't go for a negative value. Let's look at this part here in the root. We have a 4 times 4.9 times 10. We'll add that to 625 because the negatives become positive. We'll square root this. I'm going to keep my saved value. I'm going to add it to 25. I'm going to divide it by my denominator components, and you'll see our time will be 5.474. What I did over here was I utilized this minus and then this minus because they'll become positive. If I'd utilize this minus, which I have to, but the positive, I would get a negative time, and you cannot have negative time. So by using this, and this, we come up with a positive value, and the time at impact is 5.474. Remember, the time of maximum height was 2.55. It took 2.55 seconds for your snowball to go up to the maximum height. Then it takes the remainder of the time from here to go down and hit the ground. So that answer has been solved, and I'll put that right here. I'll put 5.474, and you know the units of that are seconds. So you see how everything has come about. Now we have to find the velocity at impact, and how would you go about doing that? The velocity of impact is not hard. You have to go back to the original equation. Vf is equal to Vo plus At, except here you have to use the time, which is this. If you're finding the velocity of impact, then you use the time of impact. You're going to calculate here for Vf. We're going to have the initial velocity here, 25 plus, and you know gravity here is minus 9.8 times time, 5.474. Now look what will happen. We have everything here in terms of the final velocity. Let's do it. We have a 9.8 minus times 5.474. We're getting a minus 53.6452. We'll add that to the initial velocity. I'm getting a value minus 28.65, which I'm rounding, minus 28.65 meters per second. But don't let this negative throw you off. It doesn't mean we've made a mistake. It just means that initially velocity had a positive value because it's aimed upwards, but when it's coming down, it's going in the opposite direction, so the vector has reversed. So it's just still a velocity. It still has a good magnitude, but it's aimed in the opposite direction, hence your sign has changed. So the negative velocity doesn't mean anything bad. Acceleration can be positive, minus, velocity can be positive and minus. It doesn't mean you've made a mistake. All it means is just your vector has reversed and it is in the opposite direction. So here we've got a value. Let's put it here, minus 28.65 meters per second, and we have that value done. Now all we have to do is E, and then we're done. We have to find out the maximum height reached. And how would you do that? You would go back here to your original position function. Final position is equal to your initial velocity times time plus half at square plus your initial position. And you're going to solve for this. But what will we put here in terms of our time? Since we're trying to find the maximum height reached, we're going to use the time of maximum height, 2.55. So SF is equal to VO, which is your initial velocity, 25 times the time, which is 2.55, plus half times minus 9.8, which is your acceleration, times time, 2.55 square, plus your initial height, which is 10. You have to solve all of this out, and it's not hard. It's all calculator. I would do this, then I'll add this, then I'll add that. I'll do 2.55 square times 9.8 minus divided by 2. That's this. Then I'll add 25 times 2.55 plus the initial height, 10, and that'll be 41.88 meters. 41.88 meters. So we've done this question. A snowball was thrown straight up from a height of 10 meters with an initial velocity of 25 meters per second. We found the time of maximum height, 2.55 seconds. We found the velocity at that maximum height was 0 meters per second because the velocity direction changed. The snowball, it changed its vector and it started going down. We found the time of impact, 5.474 seconds. We found the velocity of impact, minus 28.65 meters per second. And we found the maximum height reached, which is 41.88 meters. So keep in mind everything you've seen over here. Acceleration was this. We use this. Vf is equal to Vo plus At. Final velocity is equal to initial velocity plus acceleration times time. And we also use this equation right here. find out position is equal to initial velocity times time plus half at square, half acceleration times square plus initial position, and that tells you everything you need to know. Remember, acceleration and velocity are vectors. They can have positive and minus values. Time can only be positive. Position can also have a positive or a minus designation because it indeed is a vector as well. And that's about all that I wanted to show you in this particular video. Thank you for watching. Have a good day. Bye.